What's up, everyone? Today I'm going to be covering Sudoswap, which is the newest NFT AMM marketplace on the block. It's like Uniswap in terms of you're exchanging tokens on a pricing curve. Obviously, there's some caveats because it's NFTs. I'm going to be covering the main protocol interactions, which are creating a new NFT ETH pair, managing the liquidity of that pair, how tokens are swapped through that pair, and the goal is to really teach you how to pull data from across the functions, events, traces, transactions to get all the data points you need to be able to do a dashboard in Dune Analytics like this one, where you can get the total volume, fees, swaps, top traders, how much liquidity is in the protocol, and like which collections are being swapped the most every day. We'll also go through more advanced queries, such as getting the liquidity depth of a specific NFT collection on Sudoswap. So you can simulate, oh, if I was to buy 200 of a specific NFT collection, how much would it cost me? What does the pricing curve look like? And what is the slippage per trade? The last thing I'll cover is how I built custom swap tables within Dune Analytics using DBT, or for them, they call it the spellbook in their repo. I'll put timestamps for everything I cover in this video on the screen now, so you can skip to whatever is most interesting for you. Additionally, everything is written up in an article on Mir. Link is in the description down below. You can click it, check it out. It's mintable and collectible as an NFT. If you do choose to collect it, then you'll get access to my private data Telegram group where we talk about the newest protocols, help each other debug various queries, and also help each other find freelance and full-time data jobs in the space. Without further ado, let's dive into the data. In case you aren't familiar with Dune, it is a blockchain analytics platform that's open and free for everyone to run SQL queries, basically across 4 or 5 different chains at this point. Their V2 engine, which is what I'm going to be using, uses Hive SQL, and you can see that you can query the base transactions or traces tables, and also you can submit contracts for decoding, so you can get stuff like tables from the specific events you're looking for. So in this case, we're going to cover this later, but this is spot price update for each trade. Once you have these queries run, you can make visualizations and put them into custom dashboards that are really easy to drag and click around. So definitely go check it out. So Sudoswap in the first few months has already generated 10,000 ETH of volume, mostly organic. How do we break it down? I would start by thinking about Uniswap v3 if you already understand the protocol. Uniswap v3, everyone shares the same pricing curve, and you can basically choose what tick range or price range you want to provide liquidity to, and your liquidity sits in its own NFT, essentially. Sudoswap, the same thing, except not only are you choosing your pricing range, you're also choosing what kind of pricing curve you want to use, or in this case, they call theirs a bonding curve. Right now, there are 2 kinds of curves. You either have linear or exponential curves. Linear just means if I set my delta, which delta just means change in price per NFT bought or sold. If I set my delta to 0.1, then on a linear curve, the price will go up by 0.1 for every single NFT bought or sold. And for an exponential curve, you multiply it. So it'd be the price times 1.01 or divided by 1.01, depending on if the token is being bought or sold into the pool. You also get to choose what side of liquidity you want to supply to when you create your pair. So you have token, NFT, or trade. Token is just ERC20 or ETH, meaning, hey, I only want to buy NFTs, essentially is what you're saying. So you still set the spot price that you want to start buying at, the delta and the bonding curve, but people can only sell NFTs into your pair. They can't buy from your pair. You could then also do NFTs only, or you could do a trade pool where you provide both sides of the liquidity. What's important to note is that fees are only on for trade pools. So if you have a trade pool, you can turn on an owner fee and actually capture some extra revenue within your pair. If you only provide token or NFT, you do not get to set owner fees. That's really important. Protocol fees apply to all 3 types of pools. So you might be asking, what's so special about Sudoswap's AMM? We already have some AMMs like NFTX that allow you to trade fungibly with ERC20 tokens. And the main selling point, or one of the main selling points for them, is that you can control slippage a lot more granularly when you're not on like a constant product curve. They have some examples of what it looks like if you try to sell and buy NFTs on a constant product curve and how the slippage goes up to like 70% based on liquidity in the pool. Whereas because you're setting a constant delta in Sudoswap, your slippage is essentially the same across however many NFTs you trade, regardless of how many NFTs are in the pool. Something to note, and this is something we're going to cover in the liquidity depth section, is this slippage breaks down a little bit if you have a bunch of pairs that only have one or two tokens in it, and have set different spot prices. So we won't go into it now, but you can see on the sell side here that the slippage goes up to 20% pretty quickly. And that's because you're swapping across pairs. So if a single pair has a set amount of liquidity, the slippage is fairly low. But even still, with many pairs, it's typically the buy slippage is like below 1%, no matter how many you buy. Sell slippage, I think the liquidity depth just hasn't matured enough yet, but hopefully we do see that side of the curve mature more across collections in the future as well. And if you're curious about how much liquidity is in various collection pools right now and you just want to go take a look, you can go to the main Sudoswap dashboard, scroll to collection stats, and you'll be able to see which collections have had the most ETH volume total or over the last 7 days, and how much ETH liquidity and NFT liquidity is currently sitting in those pools. Click on this link if you want to go and get a deeper dive of any of the data here, and you'll be able to see essentially the same exact stats, but with more granular breakdown on like prices and like pool simulations and how individual pairs are split. So you can see for 0x mods, for example, it's mainly these 3 pairs that have all the NFT liquidity, right? And the ETH liquidity is also split across 3 pairs, which is why the liquidity depth might not be super balanced for that. All right, so now let's break down this monster chart that's sitting in the article. Again, link is in description. This is supposed to be a data guide where I'm going to walk through how we pull out all the data from the 4 various contracts that are core to this protocol, break them down into the main interactions, and build up this swaps table. We built in dbt, which we're going to cover later in this video, and that's the table that both of these dashboards are built off of. I think they query this table and one other one, which is like the create pairs contracts, and everything else is, yeah, that's the same. So the main interaction, creating a token NFT pair. You could use ERC20 or ETH. Right now, only ETH is live. There are a few ways of figuring out what's the initial liquidity of the pool. So one is just you look at the create pair function and you get the output addresses of, hey, what's the address of the pair that's created? What is the NFT contract address being used? And you can essentially look at the transfer events. So remember, ERC 721 tokens emit transfer events, and that's in a ERC 721 table, which you'll see not in this one, but that's in an ERC 721 table, which you can see if you go to abstractions and then ERC 721 event transfer. If we were to query this table, and again, you can just easily click things in here, make sure you're on the right network. So we could say, all right, looking at all the ERC 720 transfers for the NFT contract address, what is the initial balance of the pool? And you could also look through Ethereum traces, and we're going to cover this more later, so don't worry if this doesn't make sense. You could look through traces and get all of the ETH value that was transferred into the contract during this transaction. Right, so you could get all the stats on the pair address, the set curve, spot price, delta, initial liquidity, and who the owner was from these events here. The second one on managing pool liquidity and owner parameters. For figuring out the pool's liquidity, we can just still use the transfer event and transfer value from traces to figure out what is this liquidity over time. There are a few deposit and withdrawal functions for NFTs on the contract, but all of it is captured on the transfer event. So there's no point in trying to piece it together like one by one through the function calls. And that's something you'll see a lot, is like there are a lot of function calls for like making things easier for the user in the front end. But from a data perspective, we try to look for things where it's okay, what's an event or function that all of these actions pass through? You can also change the delta, the spot price, asset recipient, or of a pair whenever you want. One of the problems for this is that changing the spot price or delta through a trade versus through this pair owner function, it missed the same event. So you have to be careful that like when you're looking at spot price updated, it's not saying, oh, someone swapped at this price. It could have just been that the owner changed this to the price. And you'll see how we get around this later for swaps. So now on to the monster query itself. How do we decode and analyze all of the NFT swaps that go through the router, that go through the pairs, that go through aggregators? It's slightly non-trivial. I think I call this out lower in the article where it would have been nice if for the swap events, it told us the old spot price, the new one, the protocol fee, the owner fee, the token ID, the token IDs in the event itself. Because right now, if you looked at the contract, and this is straight from the repo, swap in out is empty, right? They don't give us any data. So we have to back into this data manually, which is fine from like, it saves gas and makes things cheaper on mainnet, but it does make a data analyst's life a little harder. So how do we get around that? Something to note on Dune Engine v2 is when a function is called, you can now capture its trace address, which means like if a function was called within a transaction, now it's decoded into the table. It used to just be the function must be called at the highest level, meaning being called by the address directly, the address submitting the transaction directly for it to show up in the tables. So what we can do is we can say, hey, find the trace address. And if you don't understand what a trace address is, I will pull up the transaction here. 1 second. So trace address, you'll see like this an array of 0, 1, 2, 3. And so this function will be trace address 0. This function here is trace address 0, 1. This is 0, 1, 2. This is 0, 1, 2, 3. You get the point, right? So we can join on trace address for a specific swap function and then look within it to say, hey, I want the total value of ETH transferred within this call, this swap call. And I also want all of the NFTs that were transferred within the swap call. So specifically what I filtered on are calls with values that aren't to the pair, because this is the protocol fee, and this is already included in this original transfer. So this is a duplicate of this. So we remove transfers that went to the pair factory, and we look for the function signature of safe transfer from, so that we can get all of the token IDs that were transferred within this call trace. And it's really important that we do this by call trace, because let's say there's multiple swaps in the same transaction. We want to get all the data within the swap, not aggregated across the transaction. It allows us to do more granular analysis in the future. So what does that look like in the actual data query? We get all of the swaps across swap NFT tokens, swap tokens for NFTs, and swap token for specific NFTs, which are like, those are the 3 swap functions on the pair. We don't care about the router because the router is going to call all these functions anyways. And what we do is we join on trace address here. So I'm saying, hey, I want to get where the call trace address is equal to the slice of the actual trace address from traces. So this is saying if this swap was called at 0, 1, 2, I want everything that's under 0, 1, 2. So I only match the pattern up until 0, 1, 2, if that makes sense. And that'll give me all of the data I want. And you can see here that we get the token IDs by filtering on this function signature, which you can check for yourself, that this is the KAKAK 256 hash of safe transfer from. And then we have to calculate base price because the ETH that was transferred is like after fees have already been calculated. So we divide the sum of the fees if it's a buy. We divide the difference of the fees if it's a sell. And that makes it easier for us to calculate the actual fees being paid to the owner and the protocol in this next CTE. There's a bunch of other stuff here that is just metadata columns for us to reach parity with NFT trades. And I'm going to cover this in DBT, but that's really the core logic for you to understand, like, how do we get the swap data within each swap event itself and not just aggregated at the transaction level. There's also some managing protocol parameters where The protocols are managed on the factory, and they can change like the protocol fee multiplier, which is right now is I think it's 0.5%, or you could change the protocol fee recipient so that you don't pay the factory, you're actually paying maybe some multi-sig governance contract, but that hasn't been implemented or changed yet. If you want to go play with this data yourself, you can go and query any of the decoded pseudo AMM Ethereum tables, or directly go and query this built table. Make sure you're using the Dune v2 engine. Your default is going to be this Ethereum v1. Oh, an important point. If you find yourself querying this and you get stuck and can't figure out how I got any of these values or charts, you can click on any of them and see exactly what logic I used in the query and how I built the tables down below. So if you still can't figure that out, then just send me a DM on Twitter. I'll try to sort it out and help you out. All right, you've made it to the advanced section. So now we're going to cover how we make PRs into spellbook. Right. So just quick history of abstractions is how we get tables like ERC20 tokens, ERC20 transfers, ERC721 transfers, NFT trades, DEX trades. That was all built in abstractions. V2, it's now called spellbook, and it follows the DBT model. So for anyone who maybe doesn't know what the DBT model is, it's essentially a transformation tool that makes it a lot easier for you to figure out what tables are flowing into what, makes it easier for you to write tests, and just has auto-generated documentation, which is a blessing in general for any kind of open source project. So to get started, you're going to first need to get Python set up on your local computer. I like to use Anaconda to basically get all of your environment management in check. You can download it for Windows, for Mac, and whatnot. There's a little finickiness in setup if things don't run when you try to test, like, for example, Conda version, and like it doesn't say, it says cannot find command. That just means you have to add things into your environmental path variables, which is as simple as just editing, going to environmental variables, clicking path, and then editing things in here. Specifically, the important one is where I have scripts. Where do I have it? It's like here. For me, it's just in this file path here. And if you OK and restart your command terminal, then you should be able to use Conda however you want. So with Conda comes pip, which is like a package installer. So all you're going to want to do is make sure you install pipm. I already have pipm installed, but dev, this is just me going into my environment, and then pip install pipenv. It's going to say, oh, you've already installed it, blah, 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 blah. That also has to be in your path variables. So just search pipm.exe, get the file location, and copy that into your environmental variables as well. Once you have that, then what you'll be able to do is go into the repo that you hopefully have already forked from GitHub. I use GitHub Desktop to manage forking. It's a little bit of a cop-out in terms of some people are like, oh, I like to use CLI for everything. And I'm like, Desktop saves me a lot of time. So just fork it into your own repository, create a new branch, and then what you're going to do is cd into that branch, make sure you're at the spellbook level, and then you're just going to do pipenv install. And what that's going to do is install all of your dependencies for stuff like Databricks and a bunch of other things. And then you're going to need to do a dbt init. I already have a profile. I'm going to overwrite it. And we're going to say, all right, we're going to want Databricks. You can put whatever you want, whatever.databricks.com. Path doesn't matter. Token doesn't matter. Don't use Unity Catalog. Schema, this is important. Schema, you have to put wizard. Don't put anything you want here. This has to be wizard. Threads, this is just concurrency on your computer. If you have a weak computer, just put 1. If you have a stronger computer, you can put like 4 to 8. And now you'll be able to do dbt docs generate, and it's going to generate your docs. We'll give it a second. It's basically building all the models, and now you can do dbt docs serve, which is going to run like a local host version of the documentation, and pop it out in the window so you can look through and see, hey, we have spellbook, models, Sudoswap is in here, and I can look at, oh, this is the Sudoswap table that Andrew helped build. what are the columns of the table, what does it reference. You can see that we reference a few different models in this query, and you can look at what is the raw SQL for the compiled versus like the more Jinja based or DBT based SQL that has kind of a little bit of weirder syntax, right? And now you can do, if I turn the server off with Control C, you can DBT compile. And what that's going to do is it's going to compile your queries so that you can look into the targets here and get whatever compiled queries you're looking for. And now these queries, if you copy them into Dune, will run perfectly fine. So that's essentially what I have here. The compiled DBT is the compiled query from the output of this command. So that's how you can then go and test things in Dune Live and see if it works. Hopefully there's going to be a cloud version or a way that you can init your profile and like directly preview and run things from your VS Code console. But before that's released, you're going to have to compile, go here, wait for it to run. Some tips and tricks is just adding some day, like time filters. And I added a contract filter just so this runs in 2 minutes for when I'm testing things. Otherwise, if you try to run and build a whole table, it's going to crash. You're not going to have a fun time. For the PR itself, I'm not going to go through it too in depth because I think that this example is a little more complex than it needs to be. What I will say is you can look into the PR's files changed to see what were the main ones that I added and changed. So you have to have a schema file, which is just the name of your table and the columns, essentially. You have to have a sources file, which these are like the main decoded contracts, like creating the pairs, swapping, the fees, all the stuff we've talked about. You don't have to put base tables like Ethereum transactions, Ethereum traces in here because those are already defined elsewhere. You need to add your model into the DBT project schema because that's the highest level one, so it knows, hey, we want to build all the tables in the Sudoswap Ethereum schema here. And you should add some tests. Here I'm just checking that the number of transactions from swaps in the raw tables is equals to the number of transactions of the swaps in the decoded, or not the decoded, in the abstracted Sudoswap Ethereum events table. You can get as fancy as you want. You can also add these tests on the schema file itself. So something I do is just check that number of items traded is not null, because if there's a swap that says there's 0 items traded, that means that I've probably decoded something wrong. And you'll see if you look through here that we've made a few PRs already because I make mistakes. Thank you, Rob and Jeff, for giving me a pair of eyes and helping me with this PR. It's a community. It's okay to make mistakes. We all learn from each other, right? Important. Incrementals. So if you're just adding like a static view of things, so let's say this one, for example, which is saying the token address, the symbol, the decimals. This is like how you would add essentially a CSV file as a table in Ethereum versus these ones, they update incrementally. Because if you run this every 5 minutes and you try to rebuild a whole table every 5 minutes, it's going to be expensive and slow. So what we do instead is we say, hey, what we want is actually let me find the incremental version. We want all of the new swaps, right? So we check for all the swaps already built into the table, take the maximum block time, which is essentially when the last process swap was, and we only get the new swap since that time. So it's incremental in terms of you just add rows to the table instead of rebuilding the whole thing. I think it's a little confusing when you're getting started because you're like, whoa, what are these brackets? And if, while, for functions inside of SQL queries. It's called Jinja. You can search it up. I linked to it in the article as well if you want to read more. Jinja's really cool in terms of it's basically easier to manage user-defined functions, I would say, that are a lot easier to write and read as well. So definitely check that out. And that's all you need to know to make a PR into the spellbook. If you have any issues or questions, again, leave a comment on the video or DM me or at me on Twitter or at Dune on Twitter. There's plenty of ways to get help or just create an issue or comment on one of these PRs. All right, now we're on to the last advanced topic of this video, and that's simulating liquidity depth across pairs. So remember that each pair has its own pricing curve, its own liquidity, which means if you try to swap 5 tokens, like 5 NFTs through a pair that only has 2 tokens worth of liquidity, it's going to have to route to another pair. So their router takes care of kind of this problem on a contract level, but from a data level, it's a little more complicated, right? So we need to get all of the pairs of a certain NFT collection, all of the pairs' current liquidities, and then we have to simulate math in terms of how does the price increase or decrease across a range of buys and sells. It sounds simple, but there's a few caveats, right? So I'm going to go through it in text first, and then I'll walk you through the query. I've done the buy side of the query in a separate live stream. You can click the link here to see me work out the query live and see how I think about building the logic of these queries live. It's only an hour long. I think it's helpful. The sell side was a little more complicated. So for buy side, you know exactly how many NFTs are already in the pairs. So you can say, hey, if there's 30 pairs here at this price and if there's 30 NFTs here at this price and there's 40 NFTs there at that price, we can just simulate it as like a row ordered curve. But for selling, you have an ETH balance and you have to basically do an arithmetic or geometric partial sum to figure out how many tokens fit into that ETH balance. I comment it through here on the sell side. I think it's in line. Let's find it. So buy depth. Yeah, so there's a CTE here where I basically simulate what is the maximum quantity that can be bought, that can be sold. And you can see there's some logarithms here. There's some weird fancy fancy fractions. I've explained it in the comments where it's saying, hey, sum of geometric series is this. We just solve for n. And for linear bonding curves, we can't use a partial sum because there's a possibility that spot price goes negative and you never get to the sum of the ETH balance. And also the pair stops fulfilling orders if your price is going negative. So essentially, instead, we just calculate, hey, when is the price going to go negative? And then we add a little logic down here later in terms of making sure the total profit you get from a pair does not go over the balance of the pair. If you have better ideas on how to do this, please let me know. I tinkered with this for a couple hours here and there, and I was like, all right, this works pretty well, runs pretty quickly. I'm not going to play with it anymore. But in terms of the actual simulation of pricing across pairs, again, once the quantity of which that can be bought and sold, then you just basically say, what is the spot price of every token bought or sold from a pair? And then you order that. So you get like an ordered prices kind of table. And then you just add a row number to it and say, all right, we have ordered prices. We can now get a row number of what does it cost per price of NFT, and just put on a curve. And now you do slippage calculation. This is where there's one other important caveat, which is when you buy a token, you're buying it not at current spot price, but you're buying it at the spot price plus 1 delta, or to the power of 1 delta. This is because, and when you sell it at the current spot price. And this is because you beat arbitraged if you're the liquidity provider and buy price and spot price are the same, because let's say you buy it, the spot price goes up by 0.1 to 1.1 ETH, and you sell it for 1.1 ETH. That's a risk-free way of making 0.1 ETH. So therefore, buy price has to be 1 delta higher. And you'll see that is in the simulation in terms of a difference of how I'm simulating the base count when it comes to sell versus buying. So that's one. I'm trying to find the example. And you also see that when I calculate slippage, I have some coalesce where for selling, your slippage for the first token is going to be 0, whereas for buying, your slippage is going to be basically 1 delta, right? And that is how we simulate prices across some set amount of selling and buying quantity. We can see the percent. Again, here, the first token has like a 3% slippage, which is, well, everything else after that is fairly low. And ideally, we basically want to see this flat on both sides. So it'll be interesting to see how this matures over time as different bonding curves are involved. Thank you so much for sticking around to the end of this video. It really means a lot to me. I hope it was helpful for you. Again, article version is linked in the description below. It's collectible as an entry, which just means you can buy it as an NFT. If you buy the NFT version, then you can join our little Telegram chat group, again, where we talk about everything data and Web3 and help you find stuff to work on. Please like, comment, subscribe as well. I'll be putting more of this content on YouTube. Go and follow me on Twitch. I know this is a lot of follows and socials, but I'm going to be testing out a bunch of different content types, seeing what's most helpful. Feel free to give me feedback in whatever form you find easiest for you, and I will see you in the next one.